Please use the link below to get the notes, questions and other videos. Don't forget to subscribe, like and share to others for our daily new videos. Mr. Godfrey, explain to us, how do mid-latitude cyclones form? And what are their impacts?
The mid-latitude cyclones, like the way the name is, mid-latitude cyclones. We quickly go back and look at this. Okay, it's called mid-latitudes. These are latitudes. These are latitudes. These are latitudes. What are latitudes? Those are imaginary lines that are drawn from west to east, increasing. In the northern hemisphere, it increases to the north. In the southern hemisphere, it increases to the south. When you look at these lines, you draw this, you draw this, you draw this one. So when you look at it, we have this segment here, and we have this segment. Where is the mid? The mid is here. So this one is the mid area of the southern hemisphere. The same way in the northern hemisphere, we have this segment here. We also have this segment. This is the mid. So that's why they call it mid-latitude cyclone, meaning that it is basically occurring between the mids of the latitudes. So it is occurring between 30 and 60, north and south of the equator, the same way north of the equator, the same way 30 and 60, south of the equator. Okay, so it's called mid-latitude cyclone. But you must not forget, learners, that mid-latitude cyclones are also known by different names. For example, it is known as a temperate cyclone. Okay, it is known as frontal depression. Okay, extratropical cyclone. Sometimes we miss that one mark in the exams because you're forgetting those simple names. But let us look here. It's called mid-latitude cyclone as it is found within the mid of the latitudes. And the cyclone is basically low pressure. When you go back to this diagram, you are going to find out that we said the mid is here. And this is where you have a low pressure. So it forms here at the subpolar, basically at 60. The same way here, it is here at the subpolar at 60. Okay, that is where it is found. But what is going to happen? That it forms because we have got the westerlies and we've got what? The easterlies from the other side. Remember, this one is called the polar easterlies, and this one is called the westerlies. These ones are warm as it is coming from the subtropical. These ones are cold as it's coming from the poles. Okay, so we must note that cold and warm fronts here exist at the mid-latitude cyclone. What you must note that when talk about mid-latitude cyclone, the first thing that should come into your mind or in your head is that cold front and the warm front. How do they exist? That will be the next thing you're going to look at. So we are going to look at the cold and warm front. We are going to look at the stages and the weather changes that come in or that exist because of the cold front. So here we go. What we must note that what is a mid-latitude cyclone? What does it mean? You must understand. We say that it forms 30 to 60. You must understand that mid-latitude cyclones are low pressure systems. It is a low pressure system. If you must note that it is a low pressure system that develops in the westerlies, traveling from west to east. Sometimes I always want to add on that it develops because of the polar easterlies and the westerly winds. Okay, so you must know that it's a low pressure system that develops in the westerlies, okay, and it travels from east to west. You must understand, why is it traveling from east to west? It is traveling from east to west because it is part of the westerlies. Remember, we said that westerly winds, what happens to the westerly winds? They travel from west to east. Since it develops here between 30 and 60, and these winds are moving from west to east, so the cyclone itself is also going to travel from west to east. That's why we say it develops within the westerlies, traveling from west, to east. You understand? The same way here, it is between 30 and 60, traveling from west to east, as it is part of the westerly belt, which is moving from west to east. Okay, what are the characteristics? What can you look at? What features can you tell? Or what can you look at to say this is exactly a mid-latitude cyclone? Please, learners, understand that the characteristics clearly tells us that this is a tropical cyclone, This is a mid-latitude cyclone, and so on and so forth. Therefore, since we are looking at a mid-latitude cyclone, what happens here? It has got two air masses, that is cold and warm front. It has got two air masses. These air masses results into the development of different fronts. Remember, we said that one air mass is coming from the polar regions, which is cold, and there's another air mass that is coming from the subpolar region, which is the westerlies, and it is warm. This results in the development of us having warm front and the cold front. In other words, when you look at mid-latitude cyclone, you know that we shall have the cold front and the warm front developing. Therefore, we also note that since it is known as a low pressure, remember when we are looking at the first thing that we looked at the beginning, we said low pressure decreases towards the center, and therefore pressure must drop below 1,000 hectopascal. We said hectopascal are the SI units of pressure, which is measured on a barometer. So pressure at the center is always below 1,000 hectopascal, decreasing towards the center. That's why it's called a low pressure. And it also says it forms all year round, but it affects Western Cape in winter. We know. Why do we say it forms all year round? Remember, this system, it moves with the apparent movement of the sun, or the ITCZ. What happens is that if it is winter in the southern hemisphere, the system moves close to South Africa. But if it is summer in the southern hemisphere, the system is forced to move further away from South Africa. That's why we say it forms throughout the year. The only fact that it only affects South Africa only during winter, but it is occurring throughout the year. All right. Then we also say that it occurs between 30 and 60. We have noted it. It's a mid-latitude cyclone, midway. The mid is here and the degrees are here. Latitudinally, it is located between 30 and 60 north and south of the equator. We go ahead and say the other names. Like I said, it's known as a temperate cyclone, frontal depression, a wave cyclone, extratropical cyclone, and so on and so forth. So those are the names that can be used to refer to a mid-latitude cyclone. Okay. Now, we must know that it does not occur once. A mid-latitude cyclone takes stages. It occurs in different stages. The stages, the first one, that's as the first stage, is what we call the initial stage. Remember on our diagram, remember this way we are going to focus specifically or mainly on South Africa. And in South Africa, we know that the cold air, or in the southern hemisphere, the cold air is in the south, the warm air is in the north. And these two air masses are coming from different directions. Okay, so the point here where the air masses are going to meet, or they are going to converge, is what we call a polar front. But what you must note that the pressure in the initial stage is still high. Because the cyclone is just starting to develop, the pressure is still above 1,000 hectopascal. That's why you see close to the boundary zone that is separating the two air masses, pressure is still above 1,006 hectopascal. We quickly go back to the diagram. I will basically use this diagram so much. When you look at this, let us first of all ignore this other northern part. Let us look at the southern part. When you look at the southern part, this is the southern hemisphere. We know that there is air that is coming from this other region, which is the polar easterly, and its meeting point is here. So as it is coming from the poles, this one at the bottom is going to be cold. We have this one that is coming from the subtropical. So since this subtropical is close to the equator, it's a bit warmer compared to the poles. Therefore, we have the northern part which has got warm air. So we have the warm air and we have the cold air. Remember, this one is coming from this way. It's meant to go the opposite direction. And this one is meant to go the other direction. So this one is called easterlies. So because it is called easterlies, it moves from east to west. Therefore, it is meant to be moving like this to the other side. And this one is meant to be moving from the west to east. Therefore, it is moving like this. So it's just bypassing each other at the subpolar low pressure here. So in that case, the way it is here is the way it is reflected the other side. Warm air above passing from, remember it is westerlies from the west going this other side. These are the easterlies from the east going this other side. That is the initial stage. What you must note with the initial stage is that it is sometimes referred to as a stationary stage because boundary is not moved at all. Okay, that's why we call it the stationary stage. We go to the second stage. The second stage is also known as the developing stage or the development stage. In other words, some other books will call it a wave stage. In this case, pressure starts to drop and a wave develops. And therefore, the rotation of the wind at a low pressure, it starts. And therefore, it rotates in that clockwise direction. Remember, we are looking at the southern hemisphere. We said in the southern hemisphere, air circulates in that clockwise direction. That's why the arrows are pointing in this direction, southwards. Therefore, this is the northern part. This one is coming from this way. This one is coming from the east. And therefore, it is rotating at a low pressure that is starting to develop in that clockwise direction. And in this case, a wave develops, and you will see that the fronts are also starting to develop. Okay. And at the apex, the pressure is dropping to below 1,000 hectopascal, but it is still high. So we got another stage, which we call the mature stage. In the mature stage, pressure drops further below 1,000 hectopascal. So therefore, here it's going to be below maybe 984 hectopascal. A cold front and a warm front is visible at this stage. So what happens here? How do you notice that this is a cold front and this is a warm front? A cold front is represented with a triangle. Okay. A warm front is represented by a semicircle. So what happens is that behind a cold front is a cold sector, and behind the warm front is a warm sector. What you must note that this cyclone is moving from west to east. So it's going into this direction, while the air is circulating in that clockwise direction. As it is rotating, the sectors of warm sector and the cold sector becomes clearly visible. And therefore, because it is visible, the warm sector is developed here. It is behind the warm front. So this is the warm front here, and here is the cold front. Therefore, behind it is the cold front. The whole of this sector here is the cold sector. Okay, so the air behind the cold sector is cold, and the air behind the warm sector is warm. What we must note that this is a mature stage, and in the mature stage, cold front and warm front are visible. They are easily identified. Okay, we go to the next stage, which we call the occlusion stage. So in this occlusion stage, we must understand that cold air is heavy and denser. Therefore, it moves faster than the warm air. This is going to force the cold front to catch up with the warm sector, narrowing the space that was occupied by the warm sector, as it is pushing the warm air outside the cyclone. So meaning that as this one catches up with the warm sector, we are going to see that at the apex, the two symbols are going to be represented. So these two symbols that are represented, there is a symbol for the warm front and the symbol for the cold front. A triangle is the cold front, the semicircle is, the triangle is the cold front, the semicircle is the warm front. Therefore, this is what we call the occlusion front. So in this occlusion front, in this stage, the occlusion, it results into the development of the occlusion front. So we have the cold air behind the cold front in the cold sector. We have the warm air in the warm sector that is behind the warm front. And this is what we call the occlusion stage. Then, in this case, when you look at these two stages, there is a characteristic that we did not mention. That characteristic that we didn't mention is that mid-latitude cyclone occur in families. We have them occurring in families. That is, there is one here, there is this one here, there is this one here. What is a family of a mid-latitude cyclone? These are series of mid-latitude cyclone. And when you look at it, it is moving from this other side of the west to the side of the east. Remember, we have a high pressure here and we have a high pressure here. Sometimes this high pressure is also known as a blocking high. It is blocking this cyclone from going into the other side. So that will force it to move so that it can move this other side, but still in the westerly direction. So what we must understand that the cold front on this other side, there is also a cold front here. There is a cold front here. There is a warm front here. It is moving from this other side to this other side. If you notice, let me say this one is A, this one is B, this one is C. Of the three, which one is mature? It's going to be that this one, A, is going to be mature. Why is it mature? Because this system is moving from west to east. Therefore, it simply means that even this one was once in the west, but because it is moving the other side, it is moving in that direction. Actually, this one is depicting almost the stages. Here, it is the initial stage, okay, when it is just starting to develop. Actually, this one could be the developing stage when it is just starting to, a wave is just starting to develop. Then this one is the mature stage. You can see that a cold front and the warm front is visible. And here you have the occlusion stage, meaning that as you move away from the west to the east, the cyclone, the stages are starting to develop. And therefore, there is a last stage, which we call the dispatch stage. Okay. The last stage will be called the dispatch what? The dispatch stage. What happens that as warm air is pushed away from the ground is going to be only occupied by the cold air. So that means the cyclone starts to die. So this one is what we say the developing stage. This one is the mature stage. This one is the occlusion stage, as it is indicated by the symbols on the diagram. Okay, so the whole of this is called a family of a mid-latitude cyclone. All right, now we must note that the occlusion stage has got two fronts. Okay, we have the warm occlusion front and the cold occlusion front, but the warm occlusion front has got the characteristics of the warm front, and the same way the cold occlusion has got the characteristics of the cold front. This is how the warm front is going to look like. What will happen that when you look at this line is gentle, okay, which is a bit different from this one. When you look at this one is stiff. This one is gentle. What happens is that as warm air reaches this point, it is forced to rise. And it is rising at this point, meaning that if these two are put together, one is here, another one here, the warm air is going to rise. And therefore, as it rises, it is going to result into the formation of clouds here, just on the cold front. So these clouds will result into the formation of heavy rainfall, and therefore heavy rainfall will be experienced on the cold front. But here we have got some kind of clouds that are going to develop. Actually, I normally use the word CAN, which is cirrus clouds, altostratus clouds, and nimbostratus clouds. These are the clouds that develop here. When you look at the shape of the clouds here, they are light and a little bit growing longer. Why are they growing longer here along the warm front? Is because of the fact that this wind, there is also some air that is moving along this, which results into it to be lengthened along the warm front. But these kind of clouds, cirrus clouds, nimbostratus clouds, and altostratus clouds. But here you can see that it's a very long cloud that is growing taller with a very flat base. So these kind of clouds are what you call the cumulonimbus clouds, and these cumulonimbus clouds are basically associated with the following weather conditions, like heavy rainfall, lightning, thunderstorms, and at times hail. So that is what we refer to as the cold and the warm front. So those conditions are going to be prevailing there. So this is how a mid-latitude cyclone will appear in the mature stage. Okay, you can see the air rotating in that clockwise way. You can see the cold, you can see the warm front. These lines here are called isobars because of this hectopascal, and then this one is called the cold front that is prevailing here. Remember, we said the cold front basically is represented by these triangle symbols. Then we also have a warm front on the other side. If you see critically, you'll find out that this warm front and the cold front are represented by different colors. Remember, warm, it's going to be red, it's a bit hot. Then cold is blue because it is colder. But what is a cold front? By the way, we're talking about cold front, we're talking about warm front. What's a cold front? A cold front is just going to be a parcel of cold air that is going to be separating the warm sector from the cold sector. It's going to be cold air along. In other words, the edge of cold air that is pushing towards the warm sector. Then we have the warm front here. So it's going to be a parcel of warm air, okay, that is in front of, or that is pushing towards this other side. So it's going to be a warm sector, a warm front. So this is a parcel of warm air, and this is a parcel of cold air. So in the center, it's a low pressure. As pressure drops further down below 1000 hectopascal. Okay, these arrows, we said it is representing the rotation of the saturation of air or the rotation of a cyclone, and we said in the southern hemisphere it is rotating clockwise. So the whole of this sector here that you see that it is shaded with the red line or red lines is going to be the warm sector. Then the whole of this sector at the bottom that is shaded with that kind of color is the cold sector. So the cold sector is covering this whole section, and the warm sector is covering that whole section. So that is basically explaining what we call the stages of a tropical, of a mid-latitude cyclone. Hope guys we are understanding each other and we are moving at the same pace. Okay, so now we must understand, before we even move here, we must know, I must explain this to you, that what happens when this cold front passes? Okay, or what happens when we reach the occlusion stage? You must know that when you reach the occlusion stage, the ground is going to be forced, the warm air is going to be forced to move away from the ground. And therefore, the ground will be basically occupied by cold air. And therefore, what will happen? The air temperature is going to decrease as the cold air is basically passing. In the same line, we shall see that the air pressure is also going to rise. It's going to be a high pressure, and therefore we shall experience stable weather condition at that particular moment. So we need to look at this. This is a synoptic weather map. And I want us to look at it and critically to see that what weather changes are caused by the cold front. Look at that. In this case, on this weather map, we have to be analytical and analyze a lot of things. When you see this weather map, look at the isobars here. The isobars are far away spaced from each other. So because the isobars are having a very big space as we're moving away from each other, it means the pressure gradient is weak. But when it is like this, when they are so close, we say it is a steep pressure gradient because isobars are so close to each other. What is the implication of this? It simply means if the pressure gradient is steep, the wind speed is going to be very high. Here, the wind speed is going to be very slow. Okay, this is the cold front here, and therefore we also have the warm front there. In the same line, we have these northwest winds. Look at this. These station models are showing us the wind direction. From the station model, it is in the northwest direction. Therefore, we say the wind is rotating in that northwest direction. Then we also look here that as it is coming here, it is in the southwest direction. As you see, it's indicated by the station model. So hope guys you understand what we mean by station model. Station model is just a symbolic element or a model that is used to explain the weather conditions that are experienced. So within here in the warm sector, the wind is moving in that northwesterly direction as it is depicted here, but here it is moving in the southwesterly direction as it is indicated there. Okay, so in that case, we have understood this. So we can see, remember in our previous map, synoptic weather map, we showed what we mean by families. These are the families whereby it is existing in series. So there is one here, there is one here, moving in this westerly direction. And you must note, we said also that cold front affects Western Cape during winter. What depicts the winter season here is that we have got a high pressure in the interior here. Okay, there's a high pressure here in the interior, which shows that it is winter in the interior here. So we can also look at the cold front, it approaching Western Cape. It approaches Western Cape basically during the winter season. But remember, we said it occurs throughout the year. Therefore, what happens is that it's winter. It is close to South Africa. And therefore, if it is summer, it will move far away, further south, away from South Africa. Okay, so we move forward. We need to understand now some of the examinable questions or some of the questions that are likely to be set. What have we looked at? We have looked at all those ones. We have looked at the cold front, the stages of the development, the initial stage, development stage. We have looked at the weather conditions that are experienced when the cold front has passed, and so on and so forth. So we need to see if they tell you to describe the weather conditions that are experienced here, what do we use? We use the station model. And this station model is clearly depicting the conditions. You see here in the warm sector, the wind direction is northwest. Here we said is southwest. Okay. This number above here is the air temperature, which we could say that the maximum temperature. Therefore, the maximum temperature within the warm sector is 24. Here, the minimum is 15. Here, where we said that this zone here is a cold sector that is occupied by cold air. Therefore, you can also look at this and you see that this one is 16, this one is 14. This way is a bit colder than what will happen here. So, at the warm front, temperature rises to the maximum. Okay, so that's why you see the warm temperature. The temperature here is 24 and 15. The difference is also not that big. But when you come here, it is 16 and 14, which is a bit lower than what is happening here. So in the warm front, air pressure drops to the minimum. We mean air pressure, atmospheric pressure drops. Why is it dropping? It is dropping because within this sector, there is rising warm air. As warm air rises above, or as warm air rises into the atmosphere, the ground or the surface is left with low pressure. That's why we say the pressure drops to the minimum. So wind direction changes from northeast to northwest or the northwest direction, as it is depicted here on the station model. So it will change. Remember, it is rising like this, but the rotation is this other side. As it is rotating like this, but this warm air is in position to rise like this. So it is going to result into this wind to move in that northwest direction. The cloud cover is also going to decrease. Okay, cloud cover is going to decrease. Why is it decreasing? Because within this sector, the warm air is rising. Therefore, it's going to be in position to force its condition to be formed along the cold front, not at the warm front. Therefore, at the warm front, because here warm air is rising on this other side, here we shall have kind of clouds like nimbostratus, the cirrus clouds, and altostratus clouds. Therefore, even the rainfall will have to drop. Why? Because there is no rising warm air. Remember, rainfall only forms when the warm air rises, condensing in the upper atmosphere to form clouds. Okay, look at the cold front. Here, the conditions we explained are on the warm front, this front here. So we need to explain what happens on this cold front. On this cold front, temperature drops. It's cold. It's the cold air that is approaching on this other side. Therefore, the temperatures are going to go further down. The air pressure is going to increase. Remember your basics. We say that if it is cold, pressure is high. If it is warm, pressure is low. So in this case, because we're experiencing very cold conditions or cold conditions on this other side, therefore, the pressure will have to drop further down. Okay, air pressure. So the wind will also change. Instead, the one that was moving here in the northwest direction is going to move in the southwest direction. So it will be because of what we call the backing, or that is what we call backing. Backing simply means the change of wind direction, okay, within this sector. We have cloud cover increasing. Cloud cover is increasing. Why is it increasing? There is rising warm air that is going to result into that wide base tall clouds along the cold front. We also have heavy rainfall. Remember, the moment we talk about those clouds, those big clouds that develop, they come with heavy rainfall. Okay, that is what we refer to as the cold weather conditions. Those are the weather conditions that are experienced on the cold front and the warm front. We also look at the weather conditions associated with the passing of the cold front after it has passed. I think on very many occasions in South Africa, you've been warned on the radio stations or TV stations that the cold front is approaching South Africa. Please wear warm, meaning that you are going to experience very cold conditions, heavy rainfall, and so on and so forth. The same way after it has passed, it causes some conditions that we are looking at right now. For example, atmospheric pressure increases. Why is it increasing? It is increasing because the cold front is passing. Remember, we said behind the cold front is cold air. That means as the cold front passes, the cold air is following. That cold air is going to result into the area being occupied by cold air, and that will result into resulting into dropping of the pressure. The increasing of the pressure. Pressure is increasing because the air is cold. As it is descending onto the Earth's surface, it will exert more pressure onto the Earth's surface. We also have very strong winds. These winds are existing because the cold front is passing. So it will be followed with very strong winds. Remember, we said that the cold front and this system is associated with a steep gradient. As I indicated to you there, and I said the steep gradient results into the winds to move or to blow very fast. Then humidity increases. Why is humidity increasing? Humidity, remember, humidity we say is the amount of water vapor in the atmosphere. So when the cold front passes, remember, it will result into humidity increasing. Why is it increasing? It is increasing because there is rising warm air along the cold front. So that rising warm air, it is warm. Remember, warm air is moist. Okay, it is moist. Because it is moist, it has got moisture embedded in that goes into the atmosphere to increase the humidity. We also have temperatures decreasing. Temperatures are decreasing, or the air temperatures are decreasing because of the fact that the cold conditions are now prevailing. There is a possibility of snow as the pressure or as the temperatures drop further down. It means it can go to even 0.0 degrees to even minus. Therefore, we shall end up experiencing snow. Cumulonimbus clouds form. Why cumulonimbus clouds form? They form because there is continuous rising of warm air along with the cold front. So when there is that rising of warm air, it will result into the development of cumulonimbus clouds in the upper atmosphere. And therefore, cumulonimbus clouds are associated with the rainfall. That's why we say there is a possibility of rainfall. That is not only, we also see that besides that, cumulonimbus clouds are associated with the thunderstorms, lightning, hail. All those weather conditions are going to be prevailing. Okay. So when this weather condition prevails, what is going to happen? Winds need to know that this mid-latitude cyclone, after it is affecting South Africa, it will have an impact to the people, to the environment, to the area where it has passed or where it is prevailing. So what are these impacts? The impacts of a mid-latitude cyclone are here. Number one, rainfall. We have just mentioned that the cold front has got cumulonimbus clouds that will result into rainfall. This rainfall is forming in winter. That's why you see Western Cape is experiencing most of its rainfall in winter. However, This heavy rainfall sometimes results into floods, and floods are likely to maybe wash away vegetation, which is an environmental effect. These floods are likely to disorganize the ecosystem. These floods are likely to damage the infrastructures, roads and bridges and so on and so forth. Therefore, you must understand, learners, that this rainfall that are caused by mid-latitude cyclone, sometimes it is good for the winter plants, but sometimes it's bad for sometimes too much floods that are going to result. Okay, it depends on the nature of the question that is asked so that you can handle it or tackle it in that way. It also increases the water table. What is the water table? Water table is the uppermost limit of the water underground. So it is going to increase as it rains, water seeps underground. That infiltration of the water underground, it results into the underground water to increase, which rises the water table. So when the water table rises, it will mean that the level of the underground water will also increase. So to those people who are interested in drilling boreholes, they can easily access the water. To the rivers that are flowing over the area where the water table is close to the earth's surface, those rivers will have ever water flowing because they will have continuity of water from the underground. So we also know that we said that it is associated with a very, very cold condition to at times leading to snow. So the frosts are likely to form, which will damage the crops, and therefore it will result into losses to farmers who are basically growing winter crops. That means it's going to negatively affect the farmers. We also know that cold temperatures are very, very strong. Cold temperatures are going to exist, and therefore these cold temperatures are also coupled with very strong winds. You know, it's cold, strong winds. You'll find that trees are uprooted, buildings are put down, bridges are damaged. All those ones are going to come because of the strong winds. And these cold temperatures, sometimes they become unbearable to people. Sometimes it even causes wastage of electricity because people have to make means to cope up with the existing environment. Therefore, they will put on heaters that will consume a lot of electricity, ending up increasing bills for people. It's a negative impact. Okay. We also know that dams are going to be filled with water. This is going to be positive because when dams are having water, that means farmers will need water for irrigation. Other places where they will need water for industrial use, they can easily collect it from the dams, or they can easily channel it from the dams. However, if the dams get full so much, it can easily break the walls and so on and so forth that are going to affect farmers. We also know that rainfall moderates the temperatures. Instead of making it so hot, it's going to make it cool because it is rainfall. We also know that more tours to the orchards and vineyards. This is because we know that because of this winter rainfall, orchards and vineyards are going to be planted or grown or are going to exist in Western Cape. So their existence, some people come to see, that is touring. Okay. Then fruits such as apples, grapes need cold temperatures. That's why you see most of our grapes or fruits that we are eating here in South Africa are basically coming from Western Cape. Okay. Thank you, learners. We have a lot of things that we're supposed to look at, but for now we are going to stop here because we need to look at the solutions. We need to look at the synoptic weather maps. We need to look at a satellite image, like here, you can say satellite image, but that will be another day. So we shall start from here. Thank you for listening. Enjoy your day.
Please use the link below to get the notes, questions and other videos. Don't forget to subscribe, like and share to others for our daily new videos. Mr. Godfrey, explain to us, how do mid-latitude cyclones form and what are their impacts?
The mid-latitude cyclones, like the way the name is, mid-latitude cyclones. We quickly go back and look at this. Okay. It's called mid-latitudes. These are latitudes. These are latitudes, these are latitudes. What are latitudes? Those are imaginary lines that are drawn from west to east, increasing. In the northern hemisphere, it increases to the north. In the southern